Hi everyone, I am Jason Kadasali. Now I'm going to answer of the following questions. Alright, questions number 1. What did you feel about studying lesson 1? Is the lesson boring and ineffective? Is the lesson interesting and effective? Alright, while I'm studying about lesson 1, I'm comfortable writing it. I feel happy during my studying, especially in part of story, because you are one among of them who are discussing about the topic. Well, enter the lesson 1 is very effective and informative, which make me wiser, knowledgeable person about the topic. Questions number 2. What are the topics encountered in lesson 1 that you find difficult to understand? Truly, the difficult to understand for me is monosaccharide structure, but I'm trying my best to understand it and find ways how I can relate either research or ask expert persons about the topic. That's why I got it. Questions number 3. What are the topics encountered in lesson 1 that you find easy to understand? Alright, the topics that I encountered in lesson 1 that easy to understand is occurrence and functions of carbohydrates. Because carbohydrates are an essential component of all organic life. Both plants and animals use carbohydrates as a primary source of energy, which keeps the body functioning at the most basic level. Carbohydrates also fulfill the other needs by helping in the synthesizing of other chemicals and providing structure for cells within the body. It is also have ability to produce energy when they undergo oxidation during respiration. The example of carbohydrates are cellulose, which are structural components of the plants, starch, the energy reservoir in plants, and glycogen, found in animal tissues and human body in smaller quantities. Questions number 4. Why do I need to learn about leaf and right-handed molecules? The right and left properties of molecules derive from the facts that carbon atoms can form bonds with 4 other atoms in such a way that if the 4 atoms attached to the carbon atoms are different, it is possible to draw 2 versions of the resulting 3-dimensional molecules that are mirror images of each other. And also, chirality is a particular important concept in biology because cells are mostly composed of chiral molecules. Small chiral molecules such as amino acids and sugar are the building blocks of larger molecules, such as proteins and nucleic acids, which are also chiral. Chirality is very important not only to life, but in biochemistry. Why? If someone stretches out their right hands to shake hands with you, can you shake their hands with your left hands? The answer is no. Of course, you cannot even if you are contortionist. Why not? Because of the chirality of your hands or the handedness of left and right hands. Try it. Right hands can clasp each other easily as can left hands. Likewise, we can slip a left gloves over a right gloves without turning the gloves inside out or inverting its chirality. What we can appreciate on a Markov scales with hands and gloves also operates on a molecular scales with sugar and proteins. Biological chemistry features a great deal of handedness. Simple sugar is a right-handed, left-handed glucose is not metabolized. Why not? Because the biological enzymes that act on the glucose are themselves handed and are not configured specially to act on left-handed glucose, even if this isomer is chemically identical to its mirror image. That's good, Bill. Thank you everyone, especially to you, mom, and to all watchers. God bless.